This video is the first of two where we will be graphing polar equations. In this video, we're going to be graphing a circle in polar coordinates. The graphs of r equals a times cosine theta and r equals a times sine of theta are circles. We want to test any polar equation that we're going to graph for symmetry. Knowing whether it has side-to-side symmetry, up and down symmetry, diagonal symmetry is going to greatly lessen the amount of work we have to do. The only way to graph polar equations is by plot pointing, and we're going to have to do all the way around the circle. So let's test for symmetry and see if we can limit the number. Three types of symmetries that we're testing for are polar axis, the line theta equals pi over 2, and the pole. For polar axis, we're replacing theta with the opposite. For our line theta equals pi over 2, we're replacing both, and the pole, we're just replacing r. R equals 4 sine of negative theta. Our negative angle identity tells us that this is going to turn into r equals negative 4 sine of theta. And that is not our original, so it's inconclusive whether or not we're going to have this kind of symmetry. For testing theta equals pi over 2, we're going to replace both. Negative r equals 4 sine of negative theta. Our negative angle identity changes our right side into negative 4 sine of theta. And if we divide both sides by negative 1, we get r equals 4 sine of theta, which is our original. So our graph is going to have symmetry with respect to the line theta equals pi over 2, which is great. So now that we know that we have side-to-side symmetry, we're only going to have to find theta values in quadrants 1 and 4 or 2 and 3. Let's see if we can make it even less with testing for symmetry with respect to the pole. We're replacing just r with negative r. There's no cleanup to do on the right. The only thing we could possibly do on the left is divide both sides by a negative. But that does not create the original. So this is a maybe. Okay, let's get to plotting some points. You'll see I filled out the chart all the way because it can be kind of tedious and time consuming, and I didn't want to do that via video. But since we have that symmetry with respect to the line theta equals pi over 2, we only have to do 2 quadrants, either the left side or the right side. I chose to do the right side. These theta values come from our first quadrant, and these theta values are our fourth quadrant. I didn't do pi over 2 because I already have 0, and we know that those are the same spot. So then what you do to get the actual points is you take this theta value and plug it into your equation and then put that into your calculator. Make sure you're in radian mode. So like the first one would be r equals, we're putting 4 sine of 0 in our calculator, and then 4 sine of pi over 6, and then 4 sine of pi over 4, and so on. So that's all you're doing. You're just plopping that in your calculator. It's like making an XY chart. We're just going horizontal instead of vertical because it's so long. That's it. But now that we have our points, let's plot them on our paper, and we'll use our symmetry to get the entire set of points, and then we'll connect our dots and make a circle. All right, so we're going to start at angle 0, which is right here, and our r value is 0. So that means we're going to go 0 rings out. So that point's right at the pole. Now careful, this graph paper looks different than the graph paper in the introduction to polar video. And I warned you about this, that this happens sometimes. You'll notice that each one of these angles is 15 degrees. And the paper we saw before only had the ones from the unit circle that we usually use. So just be careful with that. All right, so our next angle measure is pi over 6. That's this one, because this is going by 15 degrees. And our R value is 2, so we're going 2 rings out right there. Our next angle is pi over 4. And we're going 2.83 rings out. Of course, we're just estimating here. Our next angle, pi over 3. Right here. We're going 3.42 rings out. And then the last one for our first quadrant there, pi over 2. And we're going 4 rings out. Great. Moving on to our fourth quadrant angles. 3 pi over 2, that's right here. Notice that our R value is -4. It's a negative number. When plotting points in polar, when your R value is negative, you go in the opposite direction of the angle. So instead of going down, we're actually going to go up 4 rings. It's going to coincide with the point that we plotted for the angle pi over 2. Our next angle, 5 pi over 3. Again, careful there, that's 15 degrees, so we got to go 2. There's our angle, but again, we have a negative R value, so we're going to have to go in the opposite direction, 3.42 rings. Next angle, 7 pi over 4. A negative R value, so we're going to be going in the opposite direction, 2.83 rings. And then lastly, 11 pi over 6. A negative R value, we're going to be going in the opposite direction, 2 rings. Aren't you glad you only had to do half the circle? That's why testing for symmetry is so important, because this can be quite laborious. Plus, you having to plug all those values into your calculator. All right, now that we have all the points from our table, we want to get any additional points possible based on the symmetry we know. This is symmetric with about the line theta equals pi over 2, so that's side to side. So look at your points that you have. Everything that you have on the right side, you have on the left side. If you're missing anything, we're going to reflect and get it. In this example, all of the symmetry is already there. There aren't any extra points to get. Now we just need to draw in our circle. The best we can. I gotta say, I've never drawn a perfect circle anytime, much less on polar paper. But that's pretty good. All right, check out the second video where we will graph another polar equation.